Hello everyone, and I am warmly welcome to you my YouTube channel Amit Maths. I have completed BSc Mathematics, MSc Mathematics and B.Ed. I am also CTET Paper 2 qualified and have 3 years of teaching experience in mathematics. Along with teaching, I have worked as a subject matter expert mathematics at Czech India Private Limited, where I solved advanced mathematics problems and help students strengthen their concepts. My teaching approach focuses on making mathematics simple, logical, and exam oriented. In my class, you will learn every concept from the basics with clear explanations, easy tricks, NCERT based questions, examples, important questions, MCQ, and board exam strategies. Whether you are preparing for class 9, 10th, 11th, or 12th board exams, my goal is to help you build confidence and achieve excellent marks in mathematics. So let's begin our lectures. As see on your screens. And this is a polynomial of class 9th. And we will detail provide in one shot. So let's start now. As see on your screens, this is the chapter polynomial, the complete one shot master class. Okay, so begin it. What is the syllabus? What you need to know? A world versus new updates. Chapter structure. Polynomial is new divided into two distinct chapters in the new NCERT books. Okay, advanced picks. Introduction to class 10 to 11 chapter like APGP and pair of linear equation will make appearances. You get updated the low level 1 proficiency mandate testing core foundation and direct formulas. Means here you get core foundations and direct formula to apply in the polynomials, and advanced optional testing higher order thinking and complex applications. So don't panic about this field. We are covering the entire foundation syllabus in the single master class, so you are prepared for both proficiency and advanced levels. So we will proceed it. And why do learn this? The math that builds the world. The polynomial is using in civil engineering, financial market, digital technology. Okay, and what is the atoms of algebra? Means variable and constant. Variable, and what is variable and constant? Constant means definition is that a symbols having fixed value, numerical value, it will never change in given problems, as like 2 minus 5 7 pi root 2, and so you calculate any number is a constant. Examples, the boiling point of water, and the boiling point of water you already know that this is only 100 degrees Celsius. So we can write as this is it rating as a constant. This is it rating as a constant. Okay. And similarly, you can say that variable, the changing value, definition a symbol that can take any real value. It varies based on the situations. Examples x, y, z, t. It is varies. Example, you say that the daily weather temperature. You always experience the temperature of daily weather is always changes. Okay, and this is like one day 20 degrees Celsius, in 25 degrees Celsius. In summer this will be get 42 degrees Celsius also. Okay, and algebraic expression is simply a constant into variable. Example, 4 as a constant, x is a variable, so 4x is a algebraic expressions. I hope you understand it. So let's forward these lectures. And descending as a polynomial, what is a dissecting in the polynomials means coefficient and exponents. The number multiplying is the variable. Here the coefficient of x cube, here you say that minus x cube plus 4x square plus 7x minus 2. Here you see that coefficient of x cube is equal to minus 1. Variable is x. Here variable is x, and the constant of x cube, coefficient of x cube is equal to minus 1, coefficient of x square equal to 4, coefficient of x is equal to 7, and constant term is minus 2. Here you see that here x to the power 0, you know that x to the power 0 is equal to 1 provided x not equal to 0. Okay, so this is a variable and the constant terms, and you can see that The constant term is the stand-alone numbers. Technically, it is 2. This can be written as minus 2 into x to the power 0, and you know that x to the power 0 is equal to 1. So this is representing as that. Okay. Uh, we already told you the unknown value variable. This is a polynomial in one variable. Okay, the distinct pieces separated by plus or minus signs are called terms. Here you say that first terms, this is the second terms, first term, second term, third term, and the fourth term. Here you say that the distinct pieces separated by plus or minus signs are called terms. First term, second term, third term, fourth term. Means four terms polynomials. Okay. So let's begin it. The golden, it is actually a polynomial or not. How we can say the given expression is polynomial or not? The exponent of variable must be a whole number like 0, 1, 2, 3, and it has no fractions, no negative. It means we have to apply power of variable only. Power of variable, always whole number, always whole number. Any expressions in which power of variable is always whole number known as a polynomial. For examples, x square plus 2x. Here you can say that power of x is 2, this is a whole number, this is belonging to that particular set, and x is a power 1, and this is also belonging to that set. And t, here the variable is t, power is 2, and here power is 0. So both are belonging to that whole numbers. So this is a polynomial in x, and this is polynomial in t. And what is the dangers if you say that x plus x raised to the power minus 1? Here power is 1, but here power is minus 1. X to the power minus 1 means minus 1 is not in the whole number, so that this is not a polynomial in x. And here you say that 3 under root y plus y square. You know that under root y means y raised to the power 1 by 2, and y raised to the power 1 by 2, and 1 by 2 is not in the whole number. So we can say that, and this expression is not a polynomial in y. And here you say that 1 by x minus 1, and here is the also variable having power of minus 1. So this is not variable in the denominator, is not a polynomial. Okay, so you can say that this is not polynomial in x. So let's begin it. Pro tips: always simplify the expression first before checking the exponent. As like that, we can take some important examples. I say that suppose 2x cube plus 3x plus x square upon x. This is a polynomial or not? First we have to simplify it. We always not say that if the variable lies in denominator x, we always say that this is polynomial. First we have to check it. First common the x from denominator and numerator. Common x, this is equal to 2x square plus 3x plus 1 upon x. This will be simplified. X is cancelled by x. So this is a 2x square plus 3x plus 1 provided x not equal to 0. Provided x not equal to 0. This is a polynomial in x. So first we have to simplify it, and then we say that the given expression is polynomial or not. So you understand this is polynomial. Here variable x power 2 whole numbers, here variable x power 1 whole numbers, here constant term power 0 is a whole number. So we can say that this is a polynomial in x. Next proceed it. Naming by size number of terms. Monomials means first terms. A polynomial is said to be the monomial if there is only one terms, means there is no plus or minus terms separated. Okay, this is a 2x, polynomial in x, one terms. Minus 5x square, polynomial in x, only one terms. Polynomial in y, only one terms. And here you say that 2x minus 5x square, y are monomials. Binomials mean two terms, y means 2. Like that, x plus 1, polynomial in x, x square minus x, polynomial in x, u के power 15 minus u square is a polynomial in u, and both the 3x plus 1 x square minus x u power 15 minus u square are binomials. Now trinomials mean three terms. Now you can say that x square plus x square plus pi This is a polynomial in x. It had a 3 terms, so that trinomials. Y के power 4 plus y plus 5. This is a polynomial in third terms in variable y. What if there are more than 3 terms? So we generally just call a multinomial or simply a polynomial with n terms. Suppose, for examples, suppose x cube plus 2x square plus 3x plus 5. This is a polynomial with 4 terms. Okay, we just not the specific names. Okay, monomial, binomial, trinomial. Here he said that what if there are more than 3 terms? There are more than 3 terms now, and we generally just call a multinomial or simply a polynomial with 4 terms. Here 1 2 3 4 terms are there, so we can say that this is a polynomial with 4 terms. Okay, so let's begin. Next, naming by the power. In previous we discuss naming by terms, and in the next, naming by power, the degree of polynomial. The degree is the highest power of the variable in the polynomial. For examples, now say px be the polynomial. Now 3x cube plus 2x minus 3, and here is the power is 3 and power is 1 and power is 0. What is maximum power? What is maximum power in that expression? This is 3. So the degree of this polynomial, this is represented by degree of polynomial x is equal to 3. This is maximum power now. Okay, so we can say that the degree of polynomial x is equal to 3. So the degree, I already told you. And first pro tip, the constant polynomial 0 is called a 0 polynomial. Its degree is not defined. And also told you, if the maximum power is 3 and its coefficient non-zero. For example, you see that and 3x cube is its maximum power and 3 is non-zero. 3 is non-zero, so that its degree is equal to 3. Okay, and constant polynomial if degree is 0. Constant polynomial is what? If degree is 0. Form C, example 7. Linear polynomial if degree is equal to 1. As C as a form ax plus b, where a not equal to 0. Where a not equal to 0. As example 2x minus 1. Here you say that here you see that x coefficient of x is equal to, and this is non-zero. So that this is for degree 1 polynomials. Quadratic polynomial means degree 2. For example, form क्या होगा ऐसा? What is the form of this? Ax square plus bx plus c. Examples 5x square plus 3x plus pi. Here coefficient of x square is equal to 5. This is non-zero. Here a is non-zero. Okay, so this is a degree 2 polynomial. And degree 3, like example ax cube plus bx square plus cx plus d. Here a not equal to 0. Coefficient of x cube not equal to 0. If degree 3 polynomials, they are like 4x cube minus x, and a, b, c, d are real numbers. Okay, so 4x cube minus x is the degree 3 polynomial known as a cubic polynomial. And you always show if it's 0 is the 0 polynomial and its degree is not defined. Degree is not defined. Degree is not defined because its coefficient, like 0 can be written as 0 plus 0 raised to the power 1, 0 into x square, 0 into x cube, and so on. Okay, so we can say that degree is not defined because any power have a maximum value, its coefficient is always 0. So degree is not defined. Okay, so next, the value machine evaluating. As we say that, like suppose px is equal to 2x plus 3, then what is the value of polynomial at x equal to 1? So this is a p1. Just putting x equal to 1. Now 2 into 1 plus 3. This is a 2 plus 3. This is a 5. If we taking input as a 1, we get output as a 5. Now the polynomial treating as a value machines. For example, you can say that this is a machine and it is act as a polynomial px equal to 5x cube minus 2x square plus 3x minus 2. If we take input as x equal to 1, we get output is equal to what? And substitute x equal to 1 in that expressions, you get 5 into 1 cube minus 2 into 1 square plus 3 into 1 minus 2, and you get 5 minus 2 plus 3 minus 2, that is 8 minus 4, 4. Output is 4. Now p1 is, we write as p1 equal to 4. The value of px at x equal to 1 is 4. Now you can say that the polynomial is treating the value machine. If we take input, we get output as that. Okay, So notice that. Next, the zero of polynomial finding the off switch. It means that we can take then after that we can first understand with a suitable example. Suppose px is equal to 3x minus 6. So we have to find value of x at which px equal to 0. We have to find value of x for which value of x for which px equal to 0. Then all the value of x is known as a zeros of the px. For example, px equal to 0 for zeros. So this is equal to 3x minus 6 equal to 0. Now 3x is equal to 6. Now x is equal to 6 by 3. And this is equal to 2. Now if we find the value of polynomial at x equal to now 3 into 2 minus 6. This is equal to 6 minus 6. This is a 0. So 2 is a 0. 2 is a 0 of px. 2 is a 0 of px. I hope you understand it. Okay. So this is a 0 of px. If degree of px is equal to 1, then maximum number of zeros of px is equal to n. Okay. If degree of px is equal to 1, then maximum number of zeros of px equal to n. It means that a quadratic polynomial have a maximum 2 zeros, and cubic polynomial, if this is a quadratic, this is a linear, degree is equal to 1, then 1 maximum 1 zeros, maximum 1 real zeros. Okay. If quadratic, then degree is equal to 2, then maximum 2 zeros. If cubic, then degree is 3, then it has maximum 3 zeros. Okay. I hope you understand it. So begin it. The zero of polynomial finding the off switch means px is equal to 0 at which point? A zero of polynomial px is simply a number seed that makes the entire machine output 0. If pc equal to, then c is the zeros. Okay, how to find it? Set the equation to equal to 0 as I told you in previous. Px equal to 0. Prove it. Example 5 from the NCERT. Verify that whether 2 and 0 are zeros of px, so that px equal to x square minus 2x test 2. Now putting x equal to 2 in the expressions. Now 2 square minus 2 into 4 minus 4 equal to 0. This is a 4 minus 4. Here this is a 4 minus 4 equal to 0. So this is s. This is zeros. Test 0. P0. Now 2 into 0 into 0 minus 2 into 0. So this is treating as this. Here you consider P0 is equal to 0 square minus 2 into 0. Now 0 minus 0, this is equal to 0. So we can say that 0x equal to 0, the 0 of the px. Okay, s ho jayega. I hope you understand. A 0 does not have to be the number 0. 0 means not a number 0. 0 means all the possible value of x which satisfied px equal to 0. Any number that balance the equation to be 0 is a root, and it also known as the root of the polynomials. Okay, so begin it next. Graph the zeros where algebra meets geometry means at which the polynomial give the 0. It just example y equal to 2x minus 4. If we put x equal to 2, we get y equal to 0. And see the graph of the polynomial, since this is a linear equations, so its graph is simply straight lines, and it intersect the point 2 comma 0. If we put x equal to 2 and y equal to 0, we get, so satisfied the graph of this line. So this is passing through the point 2 comma 0 in the graph. Okay, so geometrically the zeros of polynomial are the exact points where the graph intersect the axis. Look at the line y equal to x minus 4. It crosses the axis at x equal to 2. So therefore algebraic check 2 into 2 minus 4, it matches the perfectly. So this is passes through the point 2 comma 0. Rule of thumb: a real polynomial degree 1 has 1 and only 1 0. It crosses the x-axis exactly once. It means that abhi previous I told you maximum number of zeros of polynomials is equal to degree of maximum number of zeros of px is equal to degree of px. Degree of px. In linear polynomial, degree is equal to 1. So the graph of the linear polynomial cut axis at a single point, exactly once. Okay, so this is written here. So next, how to form the graph of quadratic polynomials. Suppose x square plus px plus c is U-shaped curve called a parabola. It can be discussed in class 11 details. It opens upward if a greater than 0 and downwards if a less than 0. Okay. As you say that it touches the x-axis at most 2 points, intersect x at 2 points, touches x-axis at exactly 1 point, never touches the x-axis. Okay, so this is a 3 cases. As you can see that. For examples, now suppose px is equal to 3x square plus 2x minus 3. Here a is equal to 3, it is greater than 0. Here a equal to 3 and it is greater than 0. Its graph as see like that. Okay, and if downwards if a is less than 0, it means that its graph is downward edge. Okay, this is downward edge. Downward edge, it or edge it or edge it. If a is less than 0, then its graph will looks like as that, and if a is greater than 0, then its graph is look like as that. If it intersects x-axis at 2 points, touches x-axis at exactly 1 point, never touches the x-axis. From these conditions, if a greater than 0 will satisfy one of them. Okay, and if the a is less than 0, and from the given 3 conditions satisfy one of them. So let's begin next. Pulling it all together, the bridge ingenious problems. As you see that the algebra y equal to x cube minus 4x plus 3, it's find the zeros. If finding the zeros, we can simply suppose solutions. Suppose px is equal to x square minus 4x plus 3. In order to solve, we have to factorize by splitting the middle term, like 1 into 3 is equal to 4. Sorry, 1 into 3 is equal to 3, and we have to solve minus 1 into minus 3, this is equal to 3, and minus 1 plus minus 3, this is equal to minus of 4. So middle term is split as like that. So x square minus 3x minus x plus 3, and common as x minus 3 minus common x minus 3. So simply common x minus 3, this is x minus 3 into x minus 1. And for zeros, px equal to 0, as we discussed the definitions. So simply separately 0. If x minus 3 equal to 0, we get x equal to 3. And if x minus 1 equal to 0, we get x equal to 1. Okay, so you can see that, and it touches the graph 1 comma 0 and 3 comma 0. Its graph looks like it. Its graph is looks like it. This is a 0. Sorry, this is a 1 comma 0. This is a 3 comma 0. So its graph looks like it. And here a equal to 1, and this is greater than upward. Okay, so its graph is look like it. Now a civil engineer use this exact x-intercept to calculate where to place structural support to bear the weight of the bridge, as the reality is that. Okay, you can see that. What is the ultimate shortcut? The remainder theorems. Suppose if we divide px equal to 3x square plus x minus 1 by x plus 1, what is the remainder? In order to find the remainder, you have to perform these long division steps. We need not to perform. For examples, we discuss in detail it. Suppose px is equal to 3x square plus x minus 1. We will find the remainder. When px is divided by x plus 1. So we have to perform this long division method as like that. Then we find the remainder in some step. We find remainder. We do not follow these steps. We have follow shortcut. That is what, if divided by x plus 1, we put x plus 1 equal to 0 and we get x equal to minus 1. Then we find value of p at x equal to minus 1. So this is a remainder we can obtain. Now p minus 1 is the remainder. This is a remainder is equal to what? Putting just x equal to minus 1 in the expressions. This is a minus 1. And this is 3 into minus 1 whole square plus 1 minus 1 minus 1. This is minus 1. This is 3 minus 2. You will get 1. So remainder is 1. We say that if px be any polynomial, and shortcut is that, what is shortcut? And this shortcut is known as remainder theorem. This is a remainder theorem. Any polynomial, then what is remainder? If px is divided by x minus a. Just putting x minus a equal to 0, you get x equal to 8. Then remainder is nothing but polynomial of variable a. Value of polynomial at x equal to a. Just simplifies you to say that x plus 1, putting x equal to minus 1, the remainder is nothing but p of minus 1. And just putting the value of minus 1, you get the remainder. Okay. For example, and if px is equal to 3x plus 5, suppose 3x square plus 5, then what is the remainder if x minus 1 divides the polynomials? If px is divided by x minus 1, just putting x minus 1 equal to 0, you get x equal to 1. The remainder is the thing p1, and this is 3 into 1 square plus 5. This is equal to what? This is equal to 3 plus 5. This is get 8. The remainder is what? 8. We shortcut to obtain it. This is 3 into 1 square plus 5. Now this is 8. And 8 is remainder whenever x plus 1 is divided by, whenever px, x plus 1 divides px, then remainder is equal to 8. Next. This is the remainder theorem as I told you. Suppose 3x minus 2 and divide the 1 remainder. शुरू में से हाई चांसेस ऑफ कैलकुलेशन से द शॉर्टकट रिमाइंडर थ्योरम फाइंड द जीरो आर द डिवाइजर. So x plus 1 equal to 0. Putting the x plus 1 equal to 0, then x equal to minus 1, plug that 0 directly into px. Now p minus 1 is equal to 3 into minus 1, you get 1. And this is a long division. It also high chances of calculation error. The remainder is exactly pa. No long division required. Okay. If x minus a divided by px, if x minus a divides pa. Okay. So this is long division required. And this is no long division required. This is a shortcut I use. This is the remainder theorem. The factor theorem. Factor theorem means the given polynomial divides or not. You take just remainder. If remainder is equal to 0, as you told I, for example, 2 divides 4 or not. Now dividing it 2 to the 4 and remainder becomes 0. Okay. It means that if x plus a is a factor of px, if p of minus a, just remainder equal to 0. P of minus a, remainder is what? P of minus a, just putting x plus a equal to 0, we get x equal to minus a. P of minus a equal to 0. For example, x plus 2 is factor of x cube plus 3x square plus 5x plus 6. Test p of minus 2, just putting x plus 2 equal to 0. You get x equal to minus 2. just find the value of px minus 2. Putting the px is nothing but x cube plus 3x square plus 5x plus 6. If px minus 2 is equal to 0, then px plus 2 is a factor of that. So putting this minus 2 cube plus 3 into minus 2 square plus 5 into minus 2 plus 6. Now minus 8 plus 2 minus 2, 4 into 3, 12 plus 5 into minus 10, minus 2 minus 10 plus 6. This is 12 plus 6, 18, minus 8 minus 10, 18. This is equal to 0. What it as because remainder is 0. So up. So that what is, and x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. I hope you understand it. So let's begin next. Expanding our toolkit, identity, the elegant proof. Moving from binomial x plus y square equal to trinomial. Suppose t equal to x plus y, the equation become t plus z whole square. To expand using standard rule, t square plus 2tz plus z square, and putting t equal to x plus y, you get x plus y square plus 2x plus yz plus z, and multiplying this 2x plus 2y, 2xy plus 2yz plus z square. Here you expanded x square plus y square plus 2xy. You get x square plus y square plus z square plus 2xy plus 2yz plus 2zx. As I told you using the slide, as that for example, if you have to prove x plus y plus z whole square, okay, so let t is equal to x plus y, therefore x plus y plus z whole square can be written as t plus z whole square. Okay, now expand as a plus b whole square. Now t square plus z square plus 2t into z. Simplify it. Now t is nothing but x plus y, use it, plus z square plus 2, t means x plus y into z. Simplify just it. X square plus y square plus 2xy plus z square plus 2xz plus 2yz. This can be written as x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Okay, so this is a formula of x plus y plus z whole square. You can prove it. So this is explaining here. I like it. What is expand 3a plus 4b plus 5c square? Now it is stating as x. So 3a square is equal to 9a square. So this can be written as like that. 3a square x square. Suppose this is x, this is y, this is z, and putting this value here. X square plus y square means 4b square plus z square means 5c square plus 2xy, x is 3a and y is 4b plus 2yz plus 2y is 4b and z is 5c plus 2zx plus 2zx 5c and 3b, and simplified you get 9a square plus 16b square plus 25c square plus 2 3 ja 6 plus into 4 24ab plus 2 4 ja 8 5 ja 14 bc plus 2 5 ja 10 3 ja 13 ac. You get the expression answers. Okay, so this is expanding our toolkit identifies. So next we will told you already, and board exam pattern check whether the degree of the zero polynomial is not defined. I already told you degree of the zero polynomial is not defined. Find the degree of the polynomials. As I told you, this is a constant. There is no variable here. Power is x raised to the power 0, and here power is x raised to the power 0. Here power is 2. Here power is 3. Here power is 7. What is the maximum power? And its coefficient 2 is not equal to 0. Maximum power is 7. Maximum power is 7. So its degree is what? Degree is equal to what? 7. This is our answer. Okay, and which of the following is not a polynomial? As like this is a power 2 and power 1, both are whole numbers, so polynomial in x. power is 3 and power is 0. So that 3 and 0 are whole numbers, so this is a polynomial. And here you say that y square plus 5 into y raised to the power minus 1, and minus 1 is not a whole number, so this is not polynomial, so this is the correct answers. And root 2 into x plus, this is a polynomial. Here power is x raised to power 1, x to power 0, so 1 and 0 are whole numbers, so this is a polynomial, so option number C will be correct. Find the value of p if 2x minus is a factor of this. So suppose solution is that px is equal to what? Let 2x cube plus px square plus 11x plus p plus 3. If 2x minus 1 is a factor of, then 2x minus 1 equal to 0, we get x equal to 1 by 2. So we can find in next slide, we can add what is px. Px is equal to 2x cube plus px square, 2x cube plus px square plus 11x plus p. Okay, this is the equations. Px 2x square 2x cube plus px square plus 11x plus p plus 3, and say that p 2x minus 1 is a factor. 2x minus 1 is a factor. It means that 2x minus 1 equal to 0, we get x equal to 1 by 2. Therefore p 1 by 2 is equal to, means its remainder equal to 0. So we can solve it as I am putting x equal to 1 by 2. Now 2 into 1 by 2 whole cube plus p into 1 by 2 whole square plus 11 into 1 by 2 plus p plus 3. This is equal to 0. You have to solve these equations. Now solve this. Now 2 into 1 by 8. 1 by 2 means 1 by 2 whole cube equal to 1 by 8. Now p into 1 by 4 plus 11 by 2 plus p plus 3. This is equal to 0. You can solve it as like 2 4 ja 8. It divides 4 times. Now 1 by 4 plus p by 4 plus 11 by 2 plus p plus 3. We have to taking the constant as a same side and p as a same side. So we can proceed in p by 4 plus p is equal to, and 1 by 4 is taking right sides, minus 1 by 4 minus 11 by 2 and minus 3, and you can take LCM as a 4. 4 1 ja 4, p into 1 p, and here is 1, so 4p. This is equal to, you can solve it as like LCM 4s. 4 1 ja 4 minus 1, 2 2 ja 4 minus 22, 3 1 ja 1 4 ja 4 minus 3 4 ja 12. This is, so we can solve it the equations as, so p plus 4p, this is equal to 5p upon 4, and this is minus 12 minus 22 minus 34 minus 35 minus 35 by 4, and 4 is cancelled out by 4 1 ja 4. So p is equal to minus 35 by 5 minus 7 times. So p is equal to minus 7. Our answers. I hope you understand it. Proceeding next. Best case it is the architect plots. An architect is designing a rectangular plot land. The total area of the plot is given by the polynomials. Mark the what types of polynomial represent the area based on a degree. So degree is what? 1 2 3. Maximum power is 2 and coefficient is non-zero. So degree is 2. If x equal to 5 meter, what is exact area of the plot? If x equal to 5 meter, just putting the value of x equal to 5, you get the area. A5 is equal to 2 into 5 square plus 7 into 5 plus 3. You can solve it again, 88 square meters. And find a dimension length of the rectangle by factorizing the area of the polynomial. You have to factorize as it. I explain its factorizations now. 2x square plus 7x plus 3. How to factorize it? I explain it. Ax is equal to, suppose ax is equal to 2x square plus 7x plus 3. In order to factorize it, you have to, coefficient of x square is equal to 2 and constant term is equal to 3. So 2 into 3 is equal to 6. You have to factorize 6 as such that sum of the its factor is equal to 7. So now 6 can be factorized as 6 into 1, and 6 plus 1 you get 7. So we can write as 2x square plus 6x plus x plus 3, and this is 6x plus x is equal to 7, and factorize is 2x common in their terms, 2x common as x is plus 3, here x, here plus 3, and plus 1 common here, and plus x plus 3, so that common from both x plus 3, and this is 2x plus 1, and this simply say that this is factorization, this is performed as like that. So this is can also be written as this is breadth, and this is a length. Okay, I hope you understand it. So this is a breadth of the and length of the rectangles. I hope you some understand it. This is factorized using that previous methods as I told you here. So next is dangers. Avoid these common mistakes. In invisible exponents mistake, thinking 2x has a degree of 0 because there is no number there. No, here x to power 1, always 1 is here. If 2x, it means that its power is 1. Okay, so 1 is here, so degree is 1. And mistake, if dividing by x minus 2, plugging in x equal to not, if you dividing by x minus 2, you get x minus 2 equal to 0, you get x equal to 2. Okay, always positive. Yeah, always set x minus 2 equal to 0, x equal to plus 2, plug in positive 2. Okay, and the fraction variable mistake, thinking 1 by x cube plus 7 is a polynomial because the exponent 3 is positive. No, because 1 by x cube plus 7, if we common x cube, you get x cube, you get 1 by x cube, 1 plus 7 by x to power cube. So this is 1 plus 7 by x cube. You get x to power minus 3 upon 1 plus 7 x to power minus 3, and this power is minus 3, so this is not a polynomial. Okay, here explain variable in that denominator mean negative exponent minus 3, not a polynomial. I hope I understand it. So ultimate one shot concept map, anatomy and rules, variable and constant. Variable means vary with respect to given condition or time. Constant means it is constant like 1, 2, 3, as like boiling point of water, and variable daily temperature of weather. Okay, a coefficient is that like x cube plus 2x square plus 1. Coefficient of x cube is equal to 1, coefficient of x equal to 2, and constant term is 1. Whole number exponent only, and the power of polynomial whole number exponents only. Okay, and the zeros of the and graph. If px equal to 0, geometrically represent x-axis intercept parabola upward versus downward. If px is equal to quadratic polynomial ax square plus bx plus c, where a not equal to 0. If a greater than 0, then upward parabola, and if a is less than 0, then downward parabola u shape. Okay, and the core theorem is that px divisible by x minus a, then right row remainder is p. If we divide x minus a by px is divisible by x minus, then what is the remainder? Then remainder is just pa. Factor theorem, if p equal to 0, then x minus a is factor. Okay, both are remainder and factor theorem. By terms, if terms is 1, then monomial. If terms is 2, now then binomial, and term is 3, then trinomial. By degree, if degree is 0, then constant polynomial. If degree is 1, then linear polynomial. If degree is 2, then quadratic polynomial. If degree is 3, then cubic polynomial. I hope you understand it. And next is your practice assignment. You can homework checklist, you can solve it, and take the answer in the comment box. So this is our lectures of the polynomial. Thank you. Be happy and be learning. Thank you.